Good afternoon, everybody, and hello from Japan. This is a work done by my student. Unfortunately, he already graduated, so I will be presenting this study. So it's about predicting personality from some texts users post on social media, and I will explain how we do it. So first, let's go to the outline of this presentation. Well, I will explain about the task, what is personality representation, personality prediction, as a machine learning task, some related studies. Then I will explain our approach. Well, first the baseline that we built, then what kind of features we extract from data and how we combine them with the features from text embeddings. Then I will say a few words about the data and give you the results. So, well, personality has been analyzed for many years, usually in psychological studies. But recently, the advance in machine learning and deep learning has allowed us to build automatic systems that could predict personality from some data. And usually these are data generated by users, posted on internet, social networks. So there are multiple data sets available to study personality from text data. So before we start with the system explanation, we need to define how to represent the personality in computers. And for this, we use some standard representation from psychology. And there are mainly two types of personality representation. One is called Big Five Traits, which basically named as openness, consciousness, agreeableness, extroversion, and neuroticism. But in this study, we use another representation, which is based on Myers-Briggs type indicators. There are 8 indicators, which are merged into 4 axes. Basically, these axes are introversion versus extroversion, sensing versus intuiting, thinking versus feeling, and judging versus perceiving. So here you can see some definitions of what type of people are introverts, extroverts, thinkers, feelers, and so on. So personality of a person is represented by a binary, 4-digit binary vector, okay, like this. So if the person is introvert, intuitive, thinker, and perceiver, then his personality is 1010. So it's kind of basically, at most there are 16 different types of personalities that we can encode with this 4-digit binary number. So first about some other studies related to ours. Using this MBTI personality representation, there were some studies. For example, this study here uses XGBoost machine learning model. In this second study, it uses a language model called BERT. to extract features from the text. Actually, we use the system from this study as our baseline. And also, I would like to mention one of our own studies from several years ago when we used standard RNN and CNN networks with Facebook data, Facebook updates data. So this is our approach, actually our baseline system. We have users with multiple posts, okay, and each post is transformed into a document vector using document embedding approach. Well, basically this document embedding is passing this input text through a BERT model, and finally averaging the output of the BERT model. Okay. Finally, averaging the vectors for each word to obtain the single document vector. So then this document vector is passed to a standard classifier, MOP classifier, which classifies the vectors into 16 personality classes. And then we just split these 16 personality classes into 4 axes to obtain 4-digit binary vector. So what kind of statistical features we extract from the data? Well, everybody who has done some work in natural language processing, I guess, is familiar with unigram and bigram. So we extract a unigram histogram and bigram histogram for each speaker. And we use them as a feature vector. So here this figure shows this histograms, bigram histograms from 2 different users. You can see that they are quite different. So that means that we can actually use these features to distinguish between different users. Another feature that we extract is a topic distribution. Well, we assume that people with different personalities would prefer different topics to write about. So we cluster all the document vectors that we extract from our baseline into using k-means clustering. Well, the number of clusters, of course, is unknown, so we did some preliminary experiments with different number of clusters, and the 4 clusters actually gave us the best result. So we set up, fixed the number of clusters to 4. So then we, as a feature vector, we use the occupancy histogram for each user. So again, the next feature that we also extract from user data is just a simple statistics of word length in letters and document length in words. So we just take the mean and variance of the document length, and the same thing we do for the words, but here we use nested statistics. So first we find the mean and variance per document or per post, and then we use this to take the mean and variance of this mean and variance. And here is an example of feature vector for different persons. with word mean, word variance, letter mean, and letter variance. Okay, so one more feature that we also extract is the usage of emoticons. People often use them to express some emotions. And again, we assume that what kind of emotions you express mostly is related to the personality. So again, we use the emoticon distributions per user as the feature vector. And here is an example of three feature vectors for three different users. And here is a total histogram of usage from the whole corpus. So there are several emoticons that are used most often. Okay, so and now we have two types of features. One, features that come from the BERT embedding, so the document vector, and several other statistical features that I just explained. So we need to combine them. And for this, we used attention-based mechanism. But before that, since the statistical features, all of them have different dimensionality, we need to equalize their dimensions to be equal to the dimension of the feature vector for the embedding vector. So in this case, we use just a single dense layer to expand the dimensionality. Usually the dimensionality is less than this one. And then we just combine them using attention weights A, and these attention weights are computed in the standard way as a softmax of the output of one linear layer with the specific weight matrix and the input vector. So then the combined vector again is passed through a classifier, and the output is split into four type axes. Okay, so this is basically our system. And now about the data. We used Kaggle MBTI dataset. Well, it's publicly available. So it's collected from the Personality Cafe forum. This is a social network where people talk about their personality, and basically the personality is the main topic for all the posts there. So it contains data from about 8,700 users, and each user data has a label, the user's MBTI file type as a 4-digit binary number, and also it's about 50 posts of this user, and each post is in average has 35 words. So we divided our data into test, train, and validation like this. Well, we follow it other studies division, so we can compare our results, and also the same evaluation mode, which is tenfold cross validation. Well, basically what this means is that you divide your data set into test and train and validation in 10 different ways, train 10 different models, take a test, and then average the scores to get the final score. So this allows you to use the whole data set as a test. Okay, so now what kind of evaluation we did? Well, first, as evaluation metrics, we used accuracy. And F1 score, well, they are standard metrics for classification. I'm not going to explain them, probably everybody is familiar. What we did actually was we calculated accuracy not for the 16 type difficult classes of personality, but for each MBTI dimension independently. So remember, there were 4 different dimensions for different axes. So each axis is scored independently, and also we take the average of these scores. And here are the results. This is the accuracy. This is the F1 score. So here in this table, we have our baseline result that is using only the document embedding as feature vectors. So here are the results for each of these 4 axes and the average. Now we tried different various combinations of different features. Okay, but first we used each feature separately combined with the base. So for the bigram and unigram, we didn't see any big difference. It's a little bit better than the baseline. For topic, it was not better than the unigrams. This is a feature for statistics of length statistics, word and letter length. Okay, and this is emoticons. So each feature, additional feature, basically improved a little bit. So then we tried to find a combination of all these features that work the best, and this was the combination of unigram, uh, uh, document and word length statistics, and emoticons. So it improved result by almost 1%. And a similar picture you can see here in the F1 score. Again, this combination of features was the best. So we also compare our results with some other studies using the same data set. So the first one uses the standard TF-IDF features and XGBoost classifier. This is the result of our baseline of the paper from which we took our baseline. It uses bird document embeddings and MLP classifier, and this is our result. And also, I would like to note that we are using this MBTI data set, but it is a little bit specific because, as I already mentioned, the personality issues are the main topic. So people, users, tend to refer to their own MBTI type, like ISTP, ESTJ, very often in their posts. So we found that there is a quite strong correlation between the user's label and the word MBTI type words that it uses in its posts. So here you can see the heat map of this correlation, where here is the user's MBTI type, and here is the MBTI type word that is used in its posts. So you can see that for this user, its own MBTI type as a word is used most often, and so for all others. So this suggests that distribution of these words could be a very good feature to distinguish between, to predict user's personality. So we did additional experiment using only this distribution as a feature. And actually what we got is this result, so which is even better than the baseline result where we used the BERT document embeddings. And when we combine them, these two, we got the best result. But again, this is very specific for this database, and we used actually our knowledge about the data so to create this kind of feature. So to conclude, well, large language models such as BERT, well, they are very good for many downstream tasks and even for personality prediction. But what they cannot do is they cannot give you higher level features, like user level features. So we use some statistical methods to manually create such high level features, and they provide some improvement when we combine them with the embeddings of the language model. And again, knowledge-based features that basically we found for this data set, like this type of distribution, can be as good as BERT embeddings from the result, and will provide a significant performance boost. But again, this is only viable for this data set. So we cannot use this conclusion for other data sets. This has to be investigated. So this is all I have to say. If you have questions, I'll be glad to answer.
Thank you, Konstantin, for the presentation. We exceeded a little time. However, since it's the last presentation of the session, I think we still have time for questions. So if anyone would like to ask, I feel very welcome. Same procedure.
So I have some comments. So thank you, Konstantin. Very interesting approach. And I can see that it has application in several contexts. One of the example from the software engineering field is to use your approach in the context of Git repository comments. Yeah, like when we create a commit or we create a pull request, we type some comments, and then if we can find out the personality types of our team members, then based on, of course, based on these comments, yeah. So first we need to a data set to train the model again, yeah. But then we can use these personality types in this way that the Scrum Master will know, yeah, if he knows what is the personality type, then he will know how to deal with the difficult guys in the team. Because sometimes we have these difficult
I guess so,
guys. Yeah, and what is more, due to the attention mechanism, I believe that your approach is very easily, it can be very easily extended to add new features like some Git statistics.
Yes, of course. The number of features is not fixed here, so yes.
Yeah. Okay, thank you.
Hello. So congratulations for the presentation. It's quite nice topic, actually. And then
Thanks.
I might ask you regarding the emoticon, right?
Yes.
Do you think that in different part of the globe, people might react differently? And so, for example, this could be somehow ambiguous sometimes. And also there are hidden, how can I say, sentiments behind an emoticon, right? So you don't know sometimes when you are smiling because you are happy with something, or maybe or you are being sarcastic, for example. Do you think this could be, for example, a extension of your work?
Well, you see, as far as the location where you live or your background affects your personality, then you can actually use it personality prediction to distinguish between different people, as long as different areas in the world or have some different distribution of personalities. Okay, but this is very difficult because in extracting this only from texts, okay, and we here assume that users are cooperative. So that means that they don't do what you don't expect them to do.
Yeah.
So
Yeah.
yeah, so if they do use emoticons not the way they are usually used, we cannot account for that.
Yeah. Okay, so thanks and very good work, actually. Very good.
Yeah, thank you.
So maybe one last from me. As you showed us, you verified an impact of adding some particular features or group of features to the solutions and embedding them into the solutions. As we noticed that this feature encoding mechanism allows you to add any number of features. Have you considered embedding any kind of a feature selection mechanism to filter out so that you can add as many features as you would like to, and then filter out those less relevant?
Well, every feature is relevant to some extent. So that's why we think that it's better to put some weight on the feature that will basically reflect on its relevancy rather than just delete features. So this is the idea behind the attention-based combination. So you put higher weight to those features that are more relevant, and this weight is actually automatically learned during the training.
Clear? Thank you.